everyone, in this part of the lab we're going to be going over the thermistor. The thermistor is a non-linear temperature sensor. It works like a variable resistor, similar to the potentiometer. Only instead of turning a little knob at the top to change the resistance, changing temperature is what changes the resistance. Based on this fact, we can then measure the resistance of the thermistor, and from that gather the temperature of our environment. The exact equations to do this are a little complicated, and they aren't linear, so we'll go over them later. For now, what we need to be aware of is that we need to gather two data points to do this measurement. These two data points, one of them needs to be at room temperature, approximately 25 degrees Celsius, which is 77 Fahrenheit. You don't need to gather it exactly this temperature, but should be as close as possible in order to ensure the accuracy of our calibration. The second data point should ideally be taken far away from this first measurement. By this I mean that it should be significantly warmer or significantly colder where you take this measurement. That's because we're using an approximation for this, and taking two data points that are far away will increase the accuracy of this approximation. The thermistor we're using is an NTC thermistor. That means as the temperature increases, the resistance is going to decrease. This is important because the approximation we're using requires our thermistor to be an NTC thermistor. We'll go over the circuitry in order to gather our resistance measurements now. The Arduino can't measure resistance directly. Thus we'll be using a voltage divider circuit so that we can measure the voltage, and from that get the resistance. A voltage divider circuit is a circuit where the voltage from the input is stepped down to ground in multiple steps. The amount of voltage that's lost in each part is dependent on the ratio between the resistors in the voltage divider circuit. We'll be using two resistors. One is a 60 ohm resistor, and the other is the thermistor. Because the exact resistance of the thermistor changes according to the temperature, the ratio between the thermistor and the 60 ohm resistor is going to change. Thus, the amount of voltage that's lost on the resistor and the thermistor will change. We can measure the voltage that's lost across the thermistor, and from that gather what the resistance of the thermistor must be. This is the equation we'll be using in order to get the resistance of the thermistor. It assumes you build your circuit exactly like we do in the next part. If you don't, your equation will be slightly different. This is the exact voltage divider circuit that we'll be using in order to measure in the voltage, and then from that, get the resistance of the thermistor. We have a wire connecting the 5V pin on the Arduino to the top of this 60 ohm resistor. The other end of the resistor is connected to the thermistor, and the other end of the thermistor is connected to ground. In between the two resistors, we have another wire that connects to analog pin 3 on the Arduino. This will allow us to measure the voltage drop across the thermistor. From that, we can gather its resistance. The code we'll be using to gather the calibration points for the thermistor is the exact same as the code we were using in part 2. Check out that part if you want more information on how the code works. We ran the code in two different environments. One was inside at room temperature. This is the voltage value we got. When we ran this code inside of a refrigerator, this is the voltage that we got. After we got our voltage measurements, we turned them into a resistance using the equation we had earlier. Now we have two resistance, temperature, coordinate pairs. In a moment, we'll be going over some formulas that require you to put in the resistance and temperature. When you put the temperature into the formulas, make sure those temperatures are in Kelvin. Follow the formulas on the screen in order to convert your Celsius or Fahrenheit measurements into Kelvin. Remember that the output of the thermistor equation will also be in Kelvin, so you'll need to convert back. We'll use these resistance, temperature coordinate pairs in order to calculate two constants that are going to go into our thermistor formula. First, we'll calculate B. This is the equation for B. Plug in the coordinate pairs for the resistance and temperature. This is what we got when we plugged our values into the formula. Now, using B, as well as the coordinate pair for the room temperature measurement, calculate R of infinity. Now, take these values and plug them back into the original formula. Now all you need to get is a resistance measurement, plug it into the formula, and you'll get the temperature. All that's left is to update our program so that it outputs the actual temperature. To do that, go to the line where you calculate the voltage. After that, turn it into a resistance. Using that resistance, plug it into the formula you just derived. This is the exact formula that we used. Yours will look slightly different. Now convert it back to the measurement of your choice. We decided to just simply subtract 273 to convert it back to Celsius. We then finally print it to the serial monitor. When coded properly, your values in the serial monitor should make sense. Try running it in a couple different environments where you already know the temperature. This is the output we got when we ran it in the room temperature environment we were before, and this is the temperature we expected. Alright everyone, that's it for this lab. We hope you enjoyed the video and learned something new about analog sensors, and how to calibrate both linear and non-linear sensors. Make sure to like, comment, and subscribe to our channel, and in the comments below, make sure to leave any recommendations for future videos we can do, or things we can show during our videos. Feel free to leave any questions as well.